Okay, so we've looked at a lot of different characteristics of our lines. We've looked at the equation, we've looked at the slope. We're going to kind of extend that a little bit further to maybe look at really specific types of questions that you could be asked here in relation to your lines here. And I suppose pushing that idea of the equation a little bit further into maybe relating different equations of the lines to each other, and particularly with respect to slope here, because we're referring to parallel and perpendicular. So we need to recall, obviously, or remind ourselves of some things. The first being parallel lines have the same slope. So kind of straightforward enough. We expect they go in the same direction. They should have the same slope to each other. Perpendicular lines have slopes which multiply to give us -1. And we've that idea of kind of the total opposites nearly for that, or we use that word of the kind of opposite reciprocal. But they should be essentially total opposites to each other. If one is -4, the other should be 1/4. So they should be complete opposites with differing signs. Then the next thing, I suppose, is rearranging a line into a form y equals mx plus c. So that slope-intercept form tells us the slope, where it's the coefficient of x there. Okay, so if we want to find the equation of a line that is parallel or perpendicular to a given line, really what it comes down to here is us first of all recognizing that the words parallel or perpendicular should spark or should kind of ring bells in our head of like, okay, I'm looking for slope here. So that's the first step. I would determine the slope. Then I would find whichever I need. So whether it's parallel or perpendicular, adjusting appropriately. So for parallel, it's just going to be the same. For perpendicular, I may need to flip the slope, change the sign. Once I have that done, I need to use my equation of the line formula, where I need a slope and a point. I'll have the slope from the first part and the point that I ask you for the line that is parallel to a given line through a particular point, or perpendicular through a particular point, or perpendicular through the midpoint. There's loads of different ways that the question could be phrased, but just being careful, I suppose, same as we had with the general finding the equation, making sure we find slope and point in the correct way. So let's just apply that to an example or two here. The first one we'll start on the left is find the equation of the line parallel to this given line that goes through the point 2 minus 3. And now if we look at the next question as well, I'm using the same line for both. So we'll maybe just calculate or kind of work out that slope first of all. So I can see straight away that the equation of the line is written in this kind of longer general form here. And I'm not able to just read the slope off from that format. So what I want to do is I want to rewrite this equation of the line. So we'll maybe rewrite that first of all. So keeping y on its own, but bringing everything else to the other side. Okay, adjusting the signs appropriately. Essentially, you're taking away 3x and taking away 4 from each side. I'm then going to divide by -2 here to give me 3/2x plus 2. Okay, y equals 3/2x plus 2. So now, by paying attention here, or kind of by noting our first step here, we've rewritten the line in this equation for the sole purpose of being able to pick out what the slope is. And we now know that the slope of this line is 3/2. So that's our first step done. The next thing we ask ourselves as we read the question says find the equation of the line parallel. So parallel means that I'm going to have the same slope. So since it's parallel, the slope for my line is still going to be 3/2, and the point that I'm going to use is the point mentioned in the question, which is 2 minus 3. Okay, so that's the point that I'm using here. So I'm using this slope so that it's parallel, and I'm using this point because that was the one given in the question. So using my equation of the line formula then, y minus y1 equals mx minus x1, I can maybe quickly just identify the different points that I have here. So x1, y1, and slope of m. So y minus y1 is -3 here. We'll use our brackets then just to adjust for that sign. X minus x1. Okay, we have a fraction here. So what we had said, or what we kind of had done with this, I suppose, even in our fractions chapter in algebra, was to maybe choose to get rid of our fractions at this point. So we're going to multiply both sides by 2 here in order to eliminate my fraction. So that's going to end up with 2 on this side, and that becoming y plus 3, and 3 left on this side with x minus 2. So I've successfully got rid of the kind of denominator of my fraction there. So I have 2y plus 6 equals 3x minus 6. Let's bring everything over to the right hand side. So 3x minus 2y minus 12, and we'll just flip things over there to write it in the correct format with everything on the left hand side, and our answer is 3x minus 2y minus 12 equals 0. So this line is parallel to the given line. We might even notice there that there are some similarities, particularly in the first two parts here, 3x minus 2y and 3x minus 2y, and that really is because the two lines are parallel to each other. Okay, so parallel and slope and all is going to be related to those coefficients of x and y, and that's something that we explore maybe more even at Leaving Cert, but it is a little trick that we can pick up for the moment, and it might kind of help us along here. So looking now at the second question, we have the same line, but this time we're looking for perpendicular. So I'm just going to take my slope from the last part. We know that the slope of the line is 3 over 2, but if it's going to be perpendicular, then the slope that I need to use for this question is going to be minus 2 over 3. The point that I want to use is the point given in the question, which again is still 2 minus 3. And again, we can lay out our equation of the line formula, and we can fill in the relevant information. So y minus 3 equals minus 2 over 3 x minus 2. Again, we're going to get rid of our fraction here, this time multiplying both sides by 3. So we get 3y plus 3 equals minus 2x minus 2. 3y plus 9 equals minus 2x plus 4. Bringing everything over to one side, then 2x plus 3y plus 5 equals 0 as my equation of the line here. So we have an alternative equation here, this time perpendicular to the given line. So we can see how we adjust our line according to whatever the situation is that we're presented with. So if we're asked for perpendicular, then we need to make sure that we adjust our slope accordingly. If we're asked for parallel, then we keep our slope identical to what we had. Okay, and it's just kind of adjusting as required by the question there. So let's look at maybe one or two more examples of those sorts of questions, because these ones are quite common. So find the equation of the line passing through the point 1, 4. So that's the point I'm going to be using. And parallel is the part of the question that's going to tell me about the slope. Now looking at this question here, immediately I can see that my line is actually given to me in the format that I would want. So the slope is going to be 3, and because it's parallel, I'm going to be using slope of 3 in this equation. Okay, the point that I'm using is the one given in the question, 1, 4, and then it's simply a matter of filling in all that information. Let me see, sorry, I will write out my equation first, my formula, then I will fill in my values, and then it's just a matter of working that out fully. So 3x minus y plus 1, and rearrange 3x minus y plus 1 equals 0. Okay, and we get our end result there. Looking then at this last question as an example here, find the equation of the line passing through the point 2 minus 3, so that's the point I'm using here, and perpendicular, so perpendicular being the part that's going to tell me about the slope here. Our line in this case, not fully in the format we would like, but we can adjust it quite easily. So isolating y here means getting everything else onto the other side, then dividing by 4. Once we're in this format, we can immediately take out the slope as minus 1 over 4 here, but because I want it to be perpendicular, I need to take a slope of 4. So flipping it and changing the sign, so 4 over 1 or just 4. So using then my y minus y1 equals mx minus x1, we can fill in the values. Y minus 3 equals 4x minus 2. Y plus 3, 4x minus 8. Bringing everything over here to the right hand side, and then adjusting to rewrite it all on the left hand side. Okay, so I suppose here in these cases it really is just paying attention to the question, still maintaining that idea that when I need the equation of a line I need slope and point, but paying attention to the fact that in these questions, rather than us being presented with the slope or even given 2 points to work out the slope, the thing that's telling us slope here is the reference to perpendicular or to parallel. That's what's going to give me the slope here, so just making sure that you adjust appropriately for that in the given questions. But these sort of ones are quite common and are quite important to be kind of familiar and confident with.